In this section, I'd like to demonstrate how graphical programming can be used to construct new programs. Programs that are not necessarily based on patterns you observed, but something that you've planned in advance. We'll still need to work from an example, however. So here, my interest is in constructing an added variable plot. And I'm using the example that we had previously, the demographic data, and in particular the three variables: infant deaths, population per physician, and the gross national product per capita. What I have in this analysis map are two least squares fits. The first least squares fit is a regression of infant deaths on number of inhabitants per physician. The second is the regression of the GNP on the number of inhabitants per physician. The added variable plot then would be the plot of the residuals from this regression versus the residuals from this regression. That plot is used to see whether or not the GNP has anything to offer over and above the population per physician in fitting the infant deaths. So the first thing I need are the two residual vectors from each of these fits. Get the residual vector from this fit by simply extracting it. There it is. And now extract the residual vector from this fit. So I'll need to add a plot to these two, so I'll widen the analysis, getting a new node. Getting a scatter plot here. And the x variable will be this residual vector. The y variable, this residual vector. And I'm prompted for a string vector, which I'll choose to be countries for the particular example we're constructing. So the scatter plot is calculated, and we're prompted to sweep it out on the screen. There's the added variable plot. You can see that it's certainly non-linear, as might be expected given we needed to transform the data. I'll link it in the analysis map to the two residual vectors that it's based on. So constructing an added variable plot depends on these 5 nodes: the two fits, the two residual vectors, and the plot. So I'll create an analysis path that I can use to construct future added variable plots by selecting these 5 nodes. The population per physician was the x variable that we had in common between the two plots, so I'm going to call that parameter the common x. Infant deaths was the response. And the GNP per capita was the new x. So there's the analysis path constructed. Let's give this analysis path a name. Call this the added variable plot, since that's what it produces. So there's the added variable plot as a tool to be used in other analyses. If we apply this tool now to the transformed data, as an example, I've got a new analysis map in the top here containing the transformed data. And I can widen this view, adding a new kind of analysis node. A new kind of analysis node here will be the added variable plot. The parameter equivalent to the new x variable, again, will be the transformed GNP. The response is the transformed infant deaths. And the common x is, again, the transformed number of inhabitants per position. Constructs the least squares fits for this new data set. It will soon prompt us for the labels to be used in the added variable plot. So the labels, remember we're using the same data set here, so I'm going to put in countries once again. And now we're prompted for a position for the added variable plot. And here's the added variable plot on the new transform data. Okay, let me rescale that so we can get a better idea. There you can see that the transform GNP does seem to have something to offer in explaining the variability in the transformed infant deaths over and above that of the number of inhabitants per position. So there we have it. All that remains now is to take our added variable plot and add it to the toolbox for future use. In summary then, we note that with graphical programming, new programs can actually be written by interacting with the graphical display. Of course, this depends on having a graphical representation of an analysis. And the results here should be applicable to other domains which can be represented as a network on the screen.